Children, welcome to part 2 of chapter triangles, which is chapter number 7 of class 9. In the first part, we have done various congruence rule like SSS congruence rule, SAS congruence rule, ASA congruence rule, and we also did that ASS congruence rule does not hold. In this chapter, we will be doing some more congruence rules and we will be doing some more properties of triangles. Take a triangle with only two sides equal, that is an isosceles triangle. Now measure angles B and C. Are they equal? Yes. Now children, take more such triangles and check whether angles opposite to equal sides are equal. You will find that it is true. Now let us prove this. So children, now we will prove a theorem that angles opposite to equal sides of an isosceles triangle are equal. That is, we are going to take an isosceles triangle where AB is equal to AC and we are going to prove that angle B is equal to angle C. The angles opposite to equal sides are equal. For this, we need to do a construction. What is the construction? We are going to draw AD, which is the bisector of angle A. That is, it is dividing angle A into two equal parts. So let us prove this. We are going to prove that these two triangles which are formed by the bisector, they are congruent. So the two triangles are triangle ABD and triangle ACD. So which three parts are equal in the two triangles? You can see that these two sides are equal. These two angles are also equal. And what about this side? This is the common side. So this will be also equal. So AB is equal to AC as it is given. Angle BAD is equal to angle CAD by construction. Because we have constructed a angle bisector of angle A. And AD is equal to AD, which is common. So we will write that the two triangles are congruent. The triangle BAD is congruent to triangle CAD. While writing the names, we have to be careful that corresponding points should come in respective positions. And which congruence rule is being used here? Since we are taking two sides, then the included angle, then a side. So SAS congruence rule. But we have not reached what we have to show. We have to show that angle B is equal to angle C. This comes from CPCT, that is corresponding parts of congruent triangles, they are equal. So angle B is equal to angle C by CPCT. So children, we have proved that in an isosceles triangle, angles opposite to equal sides are equal. Children, is the converse of this theorem also true? That is, if in a triangle, the two angles are equal and the sides opposite to them, will they be equal? Let us see this. Now let us look at this with the help of a triangle ABC where angles B and C are equal. I have taken them to be equal to 40 degree and I have drawn a bisector of angle A which meets the base BC at D. Now let me fold this triangle along the side AB such that I will see that these two sides, they overlap each other. That is, AB is overlapping AC completely. So we can say that AB is equal to AC or the sides opposite to equal angles are equal. We can do this with a number of other triangles and we can verify it. Children, let us prove this property, that is, in a triangle, sides opposite to equal angles are equal. So here I have taken a triangle ABC in which two angles are equal, angle B and angle C. I have to prove that AC is equal to AB, that is, the sides opposite to equal angles are equal. For this, I need to make a construction, that is, I'll draw AD, the angle bisector of angle A. So this angle will be equal to this angle. Now let us try to make these two triangles congruent. So here we have two triangles ABD and ACD. What are we given? We are already given that angle B is equal to angle C. So this is given. And by construction we have that angle BAD is equal to angle CAD. This is by construction. Which other part is equal in the two triangles? AD is the common side of two triangles, so it is common. So we can write that AD is equal to AD. Which congruence rule is being used here? Now here two angles and one side are equal, but the side is not included between the two angles. So we will write that triangle ABD is congruent to triangle ACD by which rule? By AAS congruence rule. And by CPCT, that is corresponding parts of congruent triangles are equal. So AB is equal to AC, and we had to prove this, that AB is equal to AC. So here we get that if in a triangle two angles are equal, the sides opposite to them will also be equal. Let us do a question. In an isosceles triangle ABC with AB is equal to AC, the bisectors of angle B and C intersect each other at O. Join A to O, show that OB is equal to OC and OA bisects angle A. So children, here we are given that in this triangle ABC, AB is equal to AC. We are also given that BO is bisector of angle B, that is it divides angle B into two equal parts, and CO is bisector of angle C, that is it is dividing angle C into two equal parts. We had to join A and O, and we have to prove that BO is equal to OC and angle A is being bisected by AO, that is this angle is equal to this angle. So let us try to prove this. For this, first of all, we are going to see that in triangle ABC, AB is equal to AC. Two sides are equal in the bigger triangle. Two sides are equal, so the angles opposite to them will also be equal. So we will have angle C is equal to angle B. Reason being because angles opposite to equal sides are equal. Now if angle C is equal to angle B, half of angle C will also be equal to half of angle B. Now what is half of angle C? Since CO is bisector of angle C, this is also half of angle C, this is also half of angle C, but according to my requirement I am going to take this one. So I am going to take OCB as half of angle C, and similarly here I am going to take OBC. Now in this triangle, the sides opposite to equal angles will be equal. The side opposite to angle OCB is OB, so OB will be equal to the side opposite to angle OBC, that is OC. So here we have proved the first part, that is OB is equal to OC. Now we have to prove that AO bisects angle A. This can be proved if these two triangles can be made congruent. That is, that by CPCT then we can say that these two angles are equal. But how to make these two triangles congruent? Now here we know that AB is equal to AC, which was given earlier. We also know that AO is common, and this side we have just proved that it is to be equal. So we can use this, that in triangles AOB and AOC, AB is equal to AC given, BO is equal to OC proved, and AO is equal to AO common. So triangle AOB is congruent to triangle AOC. And which rule is being applied? Since three sides are equal, the rule is SSS congruence rule. but we have not reached our target, that is we have not reached that OA bisects angle O. So by CPCT we can say that BAO is equal to CAO, corresponding parts of congruent triangles. So this proves that AO bisects angle A. Children, I have a very interesting question for you. Show that angles of an equilateral triangle are 60 degree each. Now I have taken cutouts of two triangles with three sides equal. See, there are three sides 7 cm, 7.5 cm, 8 cm, and the other triangle also has three sides as 7 cm, 7.5 and 8 cm. Let us see whether they are congruent. Let us try to overlap one above the other. So you can see that from the top only the yellow triangle is visible. So they are congruent to each other. So this is SSS congruence rule, side, side, side congruence rule. You can verify this by taking a number of other triangles having equal sides. So we conclude that if three sides of one triangle are equal to three sides of another triangle, then the triangles are congruent. Let us do a question. Two sides AB and BC and median AM of one triangle ABC are respectively equal to sides PQ and QR and median PN of triangle PQR. Show that triangle ABM is congruent to triangle PQN, and the second part is show that triangle ABC is congruent to triangle PQR. So children, here we are given two triangles ABC and PQR, where AB is equal to PQ, this BC is equal to QR, AM is the median of BC, that is M is midpoint of BC, PN is the median of QR, that is N is midpoint of QR. We are also given that these two medians are equal. We have to prove two parts. The first part is that this smaller triangle, triangle ABM, is congruent to triangle PQN. And the second part is that this whole triangle ABC is congruent to triangle PQR. So let us first do the first part, that is how to prove triangle ABM congruent to triangle PQN. So in triangles ABM and PQN, let us see which three corresponding parts are equal. Now in these two triangles, we already know that AB is equal to PQ, it is given. We know that BC is equal to QR. So half of BC will be equal to half of QR, just multiplying the same number here. Now M is midpoint of BC. So half of BC can be taken to be equal to BM and half of QR can be taken to be equal to QN. So this gives me that BM is equal to QN. So which is the third side of this triangle, that is AM, which is already given to be equal to PN. So AM is equal to PN. So three sides of one triangle are equal to three sides of the other triangle. We can say that triangle ABM is congruent to triangle PQN. By which rule? By SSS congruence rule. Now let us do the second part. So in the second part, we have been asked to prove that triangle ABC is congruent to triangle PQR. That is the whole triangle to be proved to be congruent to triangle PQR. Now which parts of the two triangles are equal? We know that AB is equal to PQ. That is given. We also know that BC is equal to QR. This is also given. Now any other part which is equal, we can derive that third part from the first set of triangles proved here. We know that triangle ABM is congruent to triangle PQN. We just proved it. Now by CPCT, that is corresponding parts of congruent triangles, this angle should be equal to this angle, which is also one of the angles of the bigger triangles. So we will write that angle B is equal to angle Q because triangle ABM is congruent to triangle PQN, and by CPCT, angle ABM is equal to angle PQN. And in reference to the bigger triangles, these angles can be named like angle B and Q. So here we have in two bigger triangles, we have AB is equal to PQ, angle B is equal to angle Q, BC is equal to QR. So triangle ABC is congruent to triangle PQR by which rule? By side, angle, side. So by SAS congruence rule. Let us discuss RHS rule. Here I have taken two triangles in which there is one right angle. Hypotenuse is of equal length, that is 9 cm, and another side is of equal length, that is 7 cm. Let us check whether they are congruent. I'll try to overlap one triangle above the other. We can see that the yellow one, it completely overlaps the green one. So they are congruent to each other. This means if in two triangles having right angles, the hypotenuse and one side are equal, the two triangles are congruent. You can verify this by taking another set of such triangles. Note that this equal right angle is not included between the two equal sides. So we arrive at the following congruence rule called RHS congruence rule, where R stands for right angle, H stands for hypotenuse, and S stands for side. And it is stated as if in two right triangles, the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of other triangle, then the two triangles are congruent. Now let us do a question. BE and CF are two equal altitudes of triangle ABC. Using RHS congruence rule, prove that the triangle ABC is isosceles. Here we are given that in triangle ABC, BE is altitude to AC and CF it is perpendicular to AB. We are also given that these two altitudes or perpendiculars, they are equal to each other. We have to prove that in triangle ABC, AB is equal to AC, that is, it is an isosceles triangle. How are we going to do this? Now my strategy is that I am going to prove these two bigger angles to be equal somehow. Now because then sides opposite to equal angles will be equal. Now how to prove these bigger angles to be equal? Can we take two triangles and prove them to be congruent, and then by corresponding parts criteria these two angles will be equal? Let us see which two triangles we can take. We can take angle BFC and angle CEB. So in triangles BFC and CEB, which three parts are equal? We know that there is a right angle in both the triangles. So we write angle BFC is equal to angle CEB is equal to 90 degree. It is given. We also know that they have a common base, which is the hypotenuse of both the triangles. So BC is equal to BC, which is common. And now we also know that BE is equal to CF. It is given that these two altitudes are equal. So in these two triangles, three parts are equal, one right angle, one hypotenuse and one side. So which criteria we are going to use here? We write that triangle BFC is congruent to CEB by RHS congruence rule. Right, but we have not reached what we have to prove. Since the two triangles are congruent, their corresponding parts will also be equal. So we can write that FBC angle will be equal to ECB. You can check that I have taken the second letter, then first, then third, here also. So this is how we take the corresponding parts from the two triangles. Now this angle I have proved to be equal to this angle. So if you look at the whole triangle, angle B is equal to angle C. So this implies AB is equal to AC, because in triangle ABC, sides opposite to equal angles are equal. So this is how we have proved that AB is equal to AC. Children, now we are going to do the next topic, inequalities in a triangle. Children, so far we have studied how equal parts of two triangles lead to congruency of triangles. But sometimes parts are not equal. How do we compare them? We say one is bigger or smaller than the other. Let us study relation between unequal sides and angles of a triangle. For this, let us do an activity. Take a scalene triangle M and P. Now measure all the angles. You will find that angle M opposite to longest side is the largest angle, whereas angle P opposite to smallest side is smallest angle. So we conclude that if two sides of a triangle are unequal, the angle opposite to the longest side is larger. Now let us have a triangle with unequal angles. Let us measure its sides. We find that clearly in a triangle, side opposite to larger angle is longer. We can verify this with the help of a number of triangles. Children, let us write the measurement of these sides. We will observe that AB plus BC is greater than CA, BC plus CA is greater than AB, AB plus AC is greater than BC. On repeating this activity with other triangles, we conclude that sum of any two sides of a triangle is greater than the third side. Now children, let us do a question. In the given figure, angle B is smaller than angle A and angle C is smaller than angle D. Show that AD is smaller than BC. So children, here we are given that angle B is smaller than angle A and angle C, this is smaller as compared to angle D. We have to prove that AD, this whole line, is smaller than BC. So we will apply the inequality in both the triangles. In triangle AOB, since angle B is smaller than angle A, so the side opposite to angle B will be smaller than the side opposite to angle A. So which is side opposite to angle B? It is AO. So AO is smaller than BO. Why? Because side opposite to smaller angle is smaller. Let us mark this as statement number 1. Now let us apply the inequality in the other triangle, that is triangle COD. Here we are given that angle C is smaller than angle D. So the side opposite to angle C, it will be smaller than the side opposite to angle D. Side opposite to angle C is OD and side opposite to angle D is OC. It is the same reasoning as above. Let us now add the two statements. Adding 1 and 2, AO plus OD is less than BO plus OC. We have added the two inequalities. What is AO plus OD? It comes out to be equal to AD. So we can say that AD is smaller than BO plus OC is BC. So here we have proved that AD is smaller than BC. Children, there is a question for you. In the given figure, PR is bigger than PQ and PS bisects angle QPR. Prove that angle PSR is greater than angle PSQ. So children, in this chapter we have discussed various congruence rules like SAS congruence rule, ASA congruence rule, AAS congruence rule, SSS congruence rule, RHS congruence rule. We have also done that in a triangle, angles opposite to equal sides are equal. Sides opposite to equal angles are equal. Angle opposite to longer side is larger and side opposite to larger angle is longer. Sum of any two sides of a triangle is greater than third side. So children, you must be wondering, we have studied congruence, but how is it related to our real life? How do we use it? What is its practicality? Now children, here I have a pen with a riffle in it. If I try to replace the riffle with another riffle, it is some other brand or some other make, it just doesn't fit because the two riffles, they are not congruent. So if the second riffle had been congruent, it would have fit in the pen. Similarly, here I have a charger pen of a phone and I put it fits completely. But if I use the pin of another charger, it just doesn't fit because the two pins, they are not congruent. So see how the congruence is used in a real life. So keep practicing maths and finding mathematics around you. Thank you and have a nice day.